Alright, so continuing on, we got the comparison now. So we just talked about Rayleigh's law, right? The comparison of the phase diagram for a solution right, of a non-volatile solute solute, right, with the phase diagram for the pure solvent. All right. So according to Rayleigh's law, the vapor pressure of a solution, or of the solution, excuse me, will be lower. So P total equals P solvent plus P solute. And since this is 0, all right, it equals the mole fraction of solvent times a pure solvent, right? So it's lower. So when we have a solution, the vapor pressure is lower, less evaporates. All right, so what happens? So here's a picture. Here in blue here, and I'll highlight it first. This is the pure substance, right? And so I have my, right there is my normal melting point and my normal boiling point. Well, if we add a substance, right, the line down here doesn't change. As you can see, this doesn't change, but the new triple point comes into play, and we get a new melting point or freezing point, and we get a new boiling point. And so as you can see, these are delta T's, right? And that delta T depends on a few things, right? It depends on the solvent, the solute, it depends. So if we look, if we notice that the freezing goes down, so, right, the freezing point is always lower, and the boiling point is always higher in this situation. Okay, so the elevation of the boiling point, BP, boiling point, and the depression of the freezing point or melting point, same thing, are colligative properties. Right? They depend on the concentration of particles the concentration of the particles in the solution. Alright, so the number of particles really matters. So molecules have one particle. Something like sodium chloride has two particles, sodium ion and chloride anion, or chloride ion, which is two particles. Okay, so there's something called the Van Hoff factor. And this has to do with, it's I, we're going to call it I, and it's the number of particles produced. So for NaCl versus KNO3, potassium nitrate, versus magnesium nitrate, versus now, HCl versus, I don't know, sodium phosphate. Alright, so I for NaCl is in theory 2. Now, observation for I is actually a little less than 2. But so there's going to be a theoretical and an actual, and that's okay. Alright, KNO3, it would be 2 because there's 2 ions. Magnesium nitrate, 3 ions. HCl, 2, it's a strong acid. Sodium phosphate has 4 ions. Alright, so those are the theoretical. All molecules are 1. Sugar, right? Doesn't matter what the sugar. A protein, an amino acid, they're all 1. Weak acids are 1. Okay. Now you can actually probably measure it, and maybe it's like 1.2 or something like 1.1. There's an actual and theoretical. I expect you to only know the theoreticals. The actuals would be either told to you, or you solve for it. You solve for I. And a little note here. A little note, right? I is included in Raoult's law also. I spelled that wrong. O-U-L-T. Right? So the number of the mole fraction for the particles, that matters. It's in the mole fraction part. Okay? It's very important to have it there as well. Alright? So we lower the vapor pressure. Which means we raise the boiling point. And we lower the freezing point or melting point. And these are all caused by an increase in the disorder of the solution, which is a system, which means that, again, it's this word again, entropy driven. Alright, that'll come up later. Alright, so now, how do we calculate this? Delta T. Delta T. There's two of them, delta T and delta T. Equals K. There's a K, and it needs to be a lowercase k. K F or K B M and I. Alright, so what is this? Obviously delta T would be the change in temperature. M is the molality. The molality, not molarity, the molality. I, of course, is the Van Hoff factor. Right? K is the constant. This is the freezing point constant. and this is the boiling point constant. So whatever we're doing, whether we're freezing or we're boiling, that's what we need to use. Okay, so there's constants. They're in the chapter. In this case, in this particular book, at the time of this recording, they're in the chapter. They're not in the back of the book. I don't believe they are. Okay, I believe they're in the actual textbook. All right, so I'm going to skip ahead to 79. I believe is the next example I want to do.